Hello everyone. Before starting the lesson, try the warm-up. Determine the exact length of the missing side. So in each case, you're solving for x, but I want the exact length. So don't round any of your answers. Pause the video and try this. If you need a hint, remember the Pythagorean theorem. That's how you can solve for a missing side length in a right triangle. Remember, C is the hypotenuse, A and B are the other two sides. If you needed that hint, just pause the video and try this now. In the first case, 1 squared plus 1 squared equals x squared. So when I solve that, I get 2 is equal to x squared, which means x is equal to the square root of 2. Notice I didn't do the plus or minus square root. I just did the positive square root. Because this is a length, it's not going to be a negative value. Likewise over here, x squared plus 1 squared equals 2 squared, which means x squared equals 2 squared minus 1 squared, which is 3. So x equals the square root of 3. I stopped here because if I do these in my calculator, I will get a number that fills the screen. The decimal values don't repeat and they go on forever. So an exact answer will just be square root of 2 and square root of 3. It is exactly that, and it's not approximate. Numbers that are written as square roots are called radicals. And we're going to look at operations with radicals today in this lesson. We're going to simplify and perform operations on radicals. A radical is written as the square root of n, where n is a real number. Remember, real numbers can be natural numbers, whole numbers, integers, or any rational number. So basically, if you have the square root of any number, that's a radical. Now you can have entire radicals like these, square root of 2, square root of 3. Those are entire radicals. Or you can have mixed radicals where you have a radical multiplied by some value in front. For example, 3 times the square root of 2. Or we might call that 3 root 2 as short form. Or 4 root 3, 4 times the square root of 3. That would be a mixed radical. So the basic idea is that a radical is a number that has a square root in it. Now, a radical can be simplified if one of the factors is a perfect square. Now, here's what I mean by perfect square. 1 squared, 2 squared, 3 squared, 4 squared, whatever those equal, these are perfect squares. Notice the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, etc. If I am taking the square root of 4, I can simplify that to 2. I don't have to write it as a radical. So a radical is any number that has a square root in it, and you can simplify if the number in the square root is a perfect square. It might not be a bad idea to write out a list of the perfect squares so that you can refer to it as you work through simplifying radicals. So my first example, express each radical in simplest form. Now off to the side here, I've listed the first 10 perfect squares. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, 10 squared. If you see any of these numbers, you can simplify it. So when I'm asked to simplify the square root of 128, well, I don't see any of these numbers in there. If I did 11 squared, it would be 121. 12 squared would be 144. 128 is not a perfect square. But 128 is 64 times 2. Well, 64 is a perfect square, so I can simplify this, the square root of 64. Now, the square root of 64 times 2 is the same as the square root of 64 times the square root of 2. I can simplify the square root of 64, that's just 8, so I end up with 8 times the square root of 2. I can't simplify the square root of 2 any further because it can't be written as a product of perfect squares. So this is as simplified as this radical gets. So the square root of 128 can be simplified to 8 times the square root of 2, or 8 root 2. This is exact. We will not go further because if we try to put this in the calculator, we will get an unexact answer, or an approximate answer. Why don't you try simplifying the next one, just the next one, the square root of 63. Try to simplify it in the same way that I simplified the first one. So pause the video and try to simplify it. One way you can figure out what to do in the first step is to look at your list of perfect squares and figure out what is the highest perfect square that is also a factor of 63. Well, that would be 9. 9 times 7 is 63. 16 doesn't go into 63, neither does 25, neither does 36, and we end up getting too high. This is the highest factor that is a perfect square. So the square root of 9 is 3, and the square root of 7, we can't simplify that any further, so we just end up with 3 root 7. If you got that, try the next one, the square root of 48, simplify it. (16) is the highest perfect square factor of 48, 16 times 3, so the square root of 16 is 4. We end up with 4 root 3. Now this next one, it's really not any more difficult than the last three. We just already are starting with a mixed radical. We have a 3 in front of the square root sign, but simplify the square root of 72 in the same way. (72) has 36 as the greatest perfect square factor. 36 times 2 is 72. So when I simplify that, the square root of 36 is 6, but remember I still have that 3 in front, so at the end it's 3 times 6, which is 18, times the square root of 2. So if you have a radical, see if you can simplify it into a mixed radical by finding perfect square factors of the number. Now in this next example, I want to show you that you can add like radicals to simplify an expression. So what do I mean by like radicals? Well, it's kind of the same idea as like terms when we're simplifying an algebraic expression. 3 root 5 and negative 4 root 5 are like radicals because they have the same square root part. Likewise, negative 2 root 3 and positive 6 root 3 are like radicals because they have the same square root part. So if I group my like radicals in the same way that I group like terms in an algebraic expression, here I have 3 root 5 minus 4 root 5. Well, that's negative 1 root 5, or just negative root 5. And these like radicals, negative 2 root 3 plus 6 root 3, well, that's positive 4 root 3. So I can simplify this expression by combining my like radicals, and I end up with this expression as the simplest version, negative root 5 plus 4 root 3. I'm not going to simplify this any further because I want an exact answer, and I can't combine these because they're not like radicals. So now we get to an example like this. Simplify the expression. Well, here I have the square root of 125 minus 3 times the square root of 20. Well, we can combine the last two examples, and we can simplify this to make a mixed radical, and then see if we have like radicals that we can combine. So why don't you start by trying to simplify these as much as you can first, and then see if you can combine like radicals. If you want to try it, you can to see how you do. Well, the square root of 125 is the square root of 25 times 5. 25 was the highest perfect square that is a factor of 125. The square root of 25 is 5, so I have 5 root 5 is the same as the square root of 125. Over here, the square root of 20 is 4 times 5 under the square root sign. The square root of 4 is 2. Negative 3 times 2 is negative 6. So this simplifies to negative 6 root 5. Now I have like radicals that I can combine. 5 minus 6 is minus 1, so I have minus 1 root 5, or just minus root 5. So you can simplify radicals, and then if you have like radicals, you can combine them together to simplify even further. Now I want to show you how you can multiply radicals, and then we're going to simplify this expression after. So we have 3 root 5 multiplied by 2 root 10. Now, in the first set of brackets, remember what we're doing. We're just multiplying these two values, 3 multiplied by the root 5. And in here, it's 2 multiplied by root 10. In between the brackets, we're multiplying. So really, this is just all multiplication. So you can imagine it written like this. Now, if you're just multiplying a bunch of numbers together, the order doesn't matter. So I can do 3 times 2 before I do 3 times the square root of 5. So if the order doesn't matter, I can rewrite this as this. 3 times 2 times root 5 times root 10. It's the same thing, but I'm going to do 3 times 2. That simplifies to 6. And now I'm going to multiply these together. Root 5 times root 10. Well, that's just root of 5 times 10. I just put them underneath the same square root sign. Well, 5 times 10 is 50. So this whole thing simplifies to 6 root 50. 6 multiplied by the square root of 50. Now that I have it as a mixed radical, let's see if we can simplify this any further. Can we simplify root 50? Think about your perfect squares. Are any of those factors of 50? Well, yes, 25 is a factor of 50. 25 times 2 is 50. Now the square root of 25 is 5. So I have 6 times 5, root 2. Let's just finish this off. 6 times 5, well, that's 30, multiplied by the square root of 2, so it's 30 root 2. So this whole thing simplified down to 30 times the square root of 2. Just to recap what I did, you can multiply the numbers in front of the roots. You can multiply the numbers inside the root together inside the same square root. So I do 3 times 2 to get 6, and the square root of 5 times 10. Then I can simplify that and look for those perfect square factors to simplify even further. Now this looks more complicated, but it's really not anything you haven't seen yet. We're going to simplify this expression. Notice what we're doing. We have a number in front of the brackets with 2 terms inside the brackets. So each term in the brackets is multiplied by negative 8 root 3. Well, you know how to multiply into the brackets. You can expand, and you can simplify radicals. Why don't you pause the video and see how much of this you can do. If you need help getting started, remember, multiply to expand the brackets. This times 5 is this. This times 2 root 3 is this. Now, if you needed that hint, you should pause the video and see if you can keep going. Well, negative 8 times 5 is negative 40, so this simplifies to negative 40 root 3. Negative 8 times 2 is negative 16. The square root of 3 times the square root of 3 is the square root of 3 times 3, which is 9. Okay, well, this can't simplify any further because there are no perfect square factors of 3 other than 1. Can this be simplified? Well, yes, the square root of 9 is 3. Negative 16 times 3 is negative 48. So the whole thing simplifies to this. I'm not going to simplify it any further because these are not like radicals, so I can't simplify them. This is as simplified as this expression gets to keep an exact answer. This one is basically the same idea, except we have a different expression. It's the brackets squared. So just remember what that means. It means you're multiplying the brackets by itself. Why don't you pause the video and see if you can expand and simplify this expression? So if you need a hint to get started, this is it. Two root 3 times 2 root 3 is 2 times 2, which is 4, times root 3 times root 3, which is root 3 times 3, which is 9. So 2 root 3 times 2 root 3 is 4 root 9. 2 root 3 times root 2 is 2 root 6. Remember, the numbers in the square roots multiply together. Okay, root 2 times 2 root 3. Well, that's 2 root 6 again. And root 2 times root 2 is root 4. Well, the square root of 9 is 3. The square root of 4 is 2. 2 root 6 plus 2 root 6, these are like radicals, so that's 4 root 6. 4 times 3 is 12. 12 plus 2 is 14. They're like terms. So we have 14 plus 4 root 6 as the simplified version of this expression. Notice I can't simplify any further because these are not like radicals. This radical cannot be simplified further because none of those perfect squares are factors of 6 other than 1. And once we've simplified as much as possible, we have finished the question. And just like we can multiply with radicals, we can divide as well. So I'm going to show you how we can divide by radicals, and then I'm going to show you how to simplify this expression. I like to write division as a fraction because I can see better the patterns that I'm going to show you here. I can think of 24 root 8 divided by 6 root 2 as 24 over 6 times root 8 over root 2. I can split it up that way because I don't have any plus or minus signs in between here. I don't have to do multiplication or division in this order. I can split it up like this. And that's going to make things a little easier for myself because over here, I just have a regular fraction, 24 over 6. I can put that into lowest terms. 24 divided by 6 is 4. Okay, so I've got 4 multiplied by this, root 8 divided by root 2. Well, just like when I'm multiplying two radicals together, I can multiply the numbers within the same square root sign. I can do that when I'm dividing. So if I'm dividing two radicals, I can divide the two numbers within the same square root sign. And I can do 8 divided by 2. That's just 4. 8 divided by 2 is 4. So the square root of 8 divided by the square root of 2 is the same as the square root of 8 divided by 2, which is the same as the square root of 4. And I know that the square root of 4 is 2. So really I have 4 times 2, which is 8. So this weird looking expression, 24 root 8 divided by 6 root 2, actually simplifies to 8. So the same rules apply if you're multiplying or dividing. You can do the calculation of the two radicals within the same square root sign. Now this one's a little bit different because notice this is not 4 root 32. It's 4 plus root 32. There's a plus sign right there. So this numerator is not one number. This is two separate terms in the numerator. But we can simplify this radical like we did in the first few examples. Look for perfect square factors of 32 and see if you can simplify just this radical part for now. So pause the video and just simplify this part. "16 is a perfect square that's a factor of 32. So 32 is 16 times 2. The square root of 16 is 4. So we have 4 root 2 is the same as root 32. So we've simplified the radical part. Now let's deal with simplifying the entire expression. Let's start by going back to our previous unit on algebra when we were simplifying rational expressions. This is essentially what we're doing here. And how did we do it before? We started by factoring. So let's factor the numerator. Well, 4 is a common factor to both terms. We're left with 1 plus root 2 as the other factor. Okay, now it's a little easier to see. We've got this thing in brackets multiplied by 4 divided by 8. 4/8 is a fraction that I can simplify. They're both divisible by 4. So 4/8 reduces to 1 over 2. So 1 times 1 plus root 2 is just 1 plus root 2, and the denominator is 2. So 4 plus root 32 over 8 simplifies to 1 plus root 2 over 2. This is as simple as it gets because if I took the square root of 2 in my calculator, I would get an approximate answer. This is the exact answer, and that's what I want. Now we started the warm-up with Pythagorean theorem, and you can use that to help you start this problem. But this problem is determining the exact area of this triangle. So you also have to think about how to calculate area. It's base times height divided by 2 in case you forgot. So you'll need to find the base. You've got the height. You can divide by 2 to find the area. The trick with this question is that we need the exact area. So no rounding in your calculator. You're going to have to simplify a radical. So pause the video and see if you're up for this challenge. See if you can do it. I started with the Pythagorean theorem to solve for the missing side because I need that for the area calculation. X squared plus 6 squared equals 8 squared. When I solve for x, I get the square root of 28. Now I can simplify that radical. 4 is the greatest perfect square factor. 4 times 7 is 28. So square root of 4 is 2 times the root 7. So x is exactly 2 root 7 centimeters. Area, base times height divided by 2. So 2 root 7 times 6 divided by 2. When I simplify that fraction, 2 divided by 2 cancels out. I'm left with 6 times the square root of 7. So the exact area is 6 root 7 centimeters squared. We've looked at simplifying radicals in this lesson. We looked at how to simplify a radical by finding perfect square factors. We looked at adding like radicals to simplify an expression. And we looked at multiplying and dividing with radicals and how to simplify those expressions. So lots of simplifying radicals in the practice as you're working on it. Reach out for help when you need it.